This would be probably, I'd say, one of the more typical application story problem examples you're going to see. We're down here. We know if we look up at an angle of 37 degrees, we can see the top of this mountain somewhere off in the distance. Using modern, I'll talk slow, modern technology, we can figure out how far it is from where we are to this point on top using a laser. There were other tricks that they used over history. People have been figuring out elevations for hundreds of years using angles and using relative distances along the ground. And we'll talk about how to do that later this chapter when we do law of sines and law of cosines. I don't actually have to know this distance. I know that if I walk forward some amount, I can get a new measurement with an angle, and I can figure out how tall it is that way. That's how we were able to have fairly accurate topographical maps all the way back to the early 1900s, like 1905, 1910. But assuming we know that distance there of 3,000 feet, because it's really hard to figure out how far it is to the middle of a mountain. The question, though, is how tall is the mountain? And we can figure that out using trigonometry. First order of business. Let's establish our angle of consideration as 37 degrees. That's the angle we're going to be working with. On the triangle, that's the angle we're going to use to identify my other sides. So where would I find my opposite? That's the small h. I really don't know anything about the adjacent here. It's just sort of there. Don't know much about it. And then the hypotenuse would be 3,000 feet, right? So what trig function makes sense? Which of the three functions uses the opposite and the hypotenuse? Sine, S. Yeah. So from what we've talked about, the trig function that has the opposite and hypotenuse in it is sine. So I know the sine of 37 degrees equals some number. I can look it up. I know the hypotenuse. I'm looking for the opposite. I know the hypotenuse. That only leaves me one variable, and I can solve it for that missing variable. So I'm going to write this down. Sine of 37 degrees, in this particular case, is going to be this unknown, little h, divided by this known, 3,000 feet. Not yet. We're getting close, though. Sine of 37 degrees. If I check my trig table, 37 degrees sine is 0.6. Now, I'll print these off before you guys leave. If you don't have a scientific calculator, you can just look it up on the table. If you have a scientific calculator, you type in sine 37, you'll get 0.6. Now, if you get a different number, it means your calculator is in radian mode, not degree mode. Most calculators default to radian. So make sure you've double-checked for that. You should see a DEG or just a D somewhere on your screen. If you see RAD, rad, or just an R, it means that you're in the wrong mode. Fix it. You might also look for a button that says DRG. That will be the one that changes the angle mode. There's degrees, radians, and gradients. The last one, the gradient, was an effort to measure angles instead of a right angle being 90 to make a right angle 25.
When do you use
So a full circle instead of being 360 would be 100. And they thought that would make sense. It never caught on. So we don't use it. So sine of 37 degrees, according to my calculator or my table, is 0.6. So 3,700 feet, or sorry, 3,000 feet. Now I use algebra, and really, it's not even algebra, it's a proportion. I cross multiply, and I just get by with my handy dandy old fashioned 4-function calculator at this point. I don't even need to do anything crazy here. I'll just put in 0.6 times 3,000. I get h is equal to 1,800 feet. Yeah. This mountain must be 1,800 feet tall.